Hello, my name is Kalle and I'm a hardware designer and a engineering manager in Untitled Electronics. This is probably the biggest embedded electronics and software engineering house in Estonia. And although everyone is quite busy, I'm going to spend some time giving a background noise about how to make a prototype into a product. Well, what is a prototype? This is a philosophical question, I guess, a little, because it depends who you ask. But overall, here I can see that most of the prototypes look like this. I would call that a proof of concept prototype. The goal is very easy. You have to just show that it functions somehow at least, and maybe test a little bit. Has to be fast to assemble. Price is not so important, every individual component and wire and so on. And the problem with those things is repeatability. But when you move along and try to finalize this product, you will most likely have prototypes that look like a product. However, these are still prototypes. You design them to meet the requirements, but most of the time something is lacking, or at least you haven't been able to test everything. So you can't say whether it functions good enough. Repeatability is everything here, because without repeatability you can't really improve anything. This is why version management is most likely the most important thing here. You have to know what you're doing and what went wrong and in which version. And the work here is testing and development. It's just going in cycles. Version A, B, C, 1, 2, 3, however you call it, however you name it. And the goal is to have a product. The product looks like a prototype, ideally, at least. But it meets all the requirements there are, all the internal requirements that the marketing team or whoever has put together. It's reliable, it doesn't crash every 10 seconds. If you go to demonstrate it to a customer, you won't have demo effects. If you have demo effects, most likely are not here yet, not there yet. Production cost is an issue that you most likely will have solved by that time. Standards, compliance to them, and so on, and the product is producible. You have looked at things like design for manufacturing, design for assembly, design for tests, so on. Sounds very easy, but I can say that there is a lot of work behind it. And the most crucial thing is to have some kind of a process and documentation, because nowadays the products are, most of the products are not very easy to make. They are not like consisting of two resistors and a capacitor, so they are more complex, and this will require a team and the team working together somehow, so that you don't waste each other's time but rather help each other out. So I'm not a big advocate of the V model, but it does illustrate a little bit. But first of all, if you don't have a specification, if you haven't set your goal, then most likely you're going to run around in circles doing something that might seem very interesting for a while, but at some point you are still not having a product. Maybe you are having lunch with other startup guys and advocating that you have the next best thing next to sliced bread, but you still haven't anything to show. And this is why some documentation is needed. And if you put down the requirements on the top level, and if your product is not that complex, maybe you don't need anything else but just one living and growing specification. However, if you don't even have that, then most likely at least you're not so efficient in a job. With more complex things, actually, there are so many levels of different requirement specification and architectural design documents and so on in at least a big corporate world that you would be surprised. However, the idea is to be able to give the same job to a new person or another person, and you have to define what you want. So, and the V model demonstrates quite well the, at least the ideal world in hardware development, which is that you should test against all the requirements that are set. And this brings me to the next part, which is testing. With testing, well, it should be kind of understandable, but still the three definite parts of testing with hardware products is testing against the requirements. You have to know that what you have accomplished is what you need, at least what you need. Second thing is reliability. This is something that is taken for granted, but if you have a microcontroller or maybe even an application processor running some Linux code there, then it's not so very rare, the situation where everything works, all the functions are there, but it crashes every once in a while, or it doesn't boot up every time, that you have to go and manually reset it. It's most likely, if you're talking about the product you want to sell in hundreds of thousands, it's out of the question. You will have a failed product. This is why reliability has to be tested, and for that it's not as straightforward as testing against requirements, which ideally are written down that requirement A, the machine can tolerate up to 30 volts AC at the input. Easy to test against, but reliability is more like you have to make stress tests, cyclic tests, environmental tests, so on, so on. And if the statistics is sufficient, then most likely you will have a good night's sleep and not worry about your system crashing in the field. And the last part of testing is compliance to standards. And this can be a headache to even people who have worked in this area for tens of years. The standards are changing. They require more and more complex setups, labs, so on, and these can be very expensive, and then they are far away. And then when they fail, then you don't know really where to find the problem or the root cause. But to testing, the most important things I would want to say that, first of all, you have to make sure that the tests are sufficient, that the test coverage is good enough, but not too much. Next thing is repeatability. If the test result is not repeatable, or the problem or the past situation is not repeatable, you haven't actually tested anything. It's just a hack. And the third thing is documental proof. Once you've tested something, have a small test report. Doesn't have to be fancy, but in 6 months you won't remember what you tested, when you tested, why, and so on. It just is. I'm not a fan of documents, but life has taught me the hard way. And to finish up, although I kind of advocated hard documentation and so on, you have to balance. With quick hack you will get something very fast, and endless development will probably give you some kind of a result that you can be proud of, but you can never turn it into money. But business is money, so at the end of the day you want to sell it, not only develop it. It's fun developing, but yeah. So I went over the topic very quickly, I understand, but if anyone has any questions, I would be more than happy to discuss. Thanks.
So you can ask different things. Right now you're trying to build the first concept, but later you need to get real product. So if you have some question, please try to ask. Kalle, what is the most difficult things to get circuit board working or to get the EMC test ready or something like that? What's usually the most complicated?
Well, it's
Difficult
when
to
we
say.
started off, when I started working in this field, and some over 10 years ago, then probably getting the first prototype to work was a headache. Nowadays, most of the times our first prototypes work quite well. And we can expect some minor issues in EMC testing sometimes, and some other things. Well, you will always get problems from a point you can't expect.
Yeah. So, do you have some questions? Somebody? No? Okay, thank you, Kalle. Very good. Okay. Sulle aitäh.